Hi everybody, hi, welcome to Momentum with Vedantu guys. How are you doing? Hi Surinder, Surinder is here and Tamanna is here. Hi both of you, how are you doing? How are you doing? Everything okay? Everything okay? Yes? Alright, good. Both of you, welcome. And of course, I think there are other people as well, but I can't see the chat. The chat is always not refreshing for some reason. Yeah, Girish Gaurav is also there. Harini is also there. Very good. Hi, everybody. Hi, welcome to Momentum with Vedantu. Today was supposed to be our last session on thermodynamics, KTT and thermodynamics and thermal physics in general. Today was supposed to be our last session, guys, and I will try to finish it today, but there might be one more session. There might be one more session. Okay, there is a reason for that. We planned it for 14 sessions, and today is the 14th session. It is supposed to finish today, but there might be a 15th session. Okay, I'm sorry for that, but it sometimes it gets out of hand. Okay, sometimes it just gets out of hand. So I'm good, Tamanna. I am very good. I don't know how are you, Girish and Tamanna, both of you, and Surinder. How is everybody? Tell me. Tell me in the chat, guys, how are you doing? First of all, I hope everybody can hear me properly. Okay, so guys, let's start today's session. First of all, very good. Tamanna is fine. I hope Surinder is also fine, and I hope Girish is also fine. So, guys, let's start today's session. If you are new here, I suggest you please like, share, and subscribe to our channel. All right, Surinder is absolutely amazing. Surinder, by the way, once again the winner of our Hall of Fame question. He gave the first correct answer minus 50 joules. Okay, so I will get that. That is always Surinder is always first. Okay. Hi Kaushik. Kaushik is also here. Hi Kaushik. How are you? How is everybody doing? Super. Yeah. Kaushik, just one. This was supposed to be the last class, but probably one more class. Okay, but not more than that. This I will try to finish it today only. Let's see. Okay. This was supposed to be the last class, but probably one more class. Okay. And then for the next chapter, we will do a poll in the Telegram group. Okay, don't worry, guys. Okay, so guys, next is so the first thing is let's recap what we studied last time. Okay, so last time, guys, if you guys remember, we studied work and we studied change in internal energy. These two concepts we studied for these three processes: isobaric, isochoric, and isothermal. Okay, all these hi Fab Phoenix. Okay, it's okay, Fab Phoenix. Hi, Kayur. Hi, everybody. All right. No, Kaushik, after completing this lesson, what we'll do is we will probably do one session for solving questions. Okay, I want to do a session on solving questions because it's just been theory. Okay, so guys, let's just revise what we have done so far. Okay, if you remember for isobaric process, pressure is constant, or you can write that volume upon temperature is also constant. Okay, for an isochoric process, volume is constant, so you can write that the ratio of pressure and temperature will remain constant. Why am I saying this, guys? Why am I saying this? Because in general, I always have one equation which is valid, which is PV is equal to nRT. So from that equation, if pressure is constant, then V by T will be constant. If volume is constant, then P by T will be constant. For an isothermal process, guys, temperature is constant, or I can also say that pressure into volume is constant. Okay, adiabatic we haven't studied so far, so we'll talk about it in some time. Okay, and work done also we calculated formulas for each of them. This was P into V final minus V initial, the work done, or it was mu into not mu, N into R into T final minus T initial. Okay, similarly for isochoric process, the work done was equal to 0, and for isothermal process, the work done was equal to nRT ln V final minus upon V initial. But here, if you remember, the single formula had 6 different versions. What were the 6 different versions, and how did I calculate that? So you had to remember that P initial V initial was equal to P final V final, and that was equal to N into R into T. So using this, you can calculate all the 6 versions of the formula. Okay, NRT, instead of NRT here, you can substitute P initial, V initial, you can substitute P final, V final. And instead of VF by VI, guys, from this you can write PI by PF and you can substitute it there. Okay, so that was the formula for this work done in case of this. क्या बोलते हैं इसको? uh, isothermal process. Now, as far as internal energy is concerned, guys, as far as internal energy is concerned, then you know what? I'll just write down the formulas. For internal energy, we have various different formulas, but let's write them one by one. For isobaric process, the change in internal energy is F by 2 into P final V final minus P initial V initial. Okay, and it is also equal to F by 2 into N into R into T final minus T initial. Do you remember this formula? Do you remember this formula? Yes, yes, yes. And then this formula is still the same. It's still the same formula here as well. And here also still the same formula. But if you substitute the values, you will get the answer as 0. If you substitute the values, you will get the answer as 0. Okay, now I have not taught you guys adiabatic process, but here also remember the formula is still the same. F by 2 into P final V final minus P initial V initial, or F by 2 into N into R into T final minus T initial. Okay. No, there has been just one assignment, Kaushik. Sir, I will give you two more assignments. Okay, I'll give you two more assignments. Don't worry. I was supposed to give it earlier. I will give it now. Okay. So we have talked about work done and change in internal energy so far. Let's entertainment 2015 high. Let's start and continue forward. Okay, welcome to the class, everybody. Let's start the class right now. Now, guys, in the last class, we talked about work done and change in internal energy. Then, finally, let's talk about the first law of thermodynamics. Let's talk about the first law of thermodynamics. The first law of thermodynamics, guys, you have to remember is based on law of conservation of energy. Okay, it is based on law of conservation of energy, basically based on the fact that energy cannot be created nor it can be destroyed for an isolated system. It can only change its form from one form to another form. Okay, now first law of thermodynamics defines internal energy as equal to the difference of blah 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 blah. What? So I will like in forget about this. Let me explain it using a diagram. So if I have a system, guys, if I have a system, then in this case, if I give some heat to this system, if I give some heat to this system, okay, then if I give some heat to this system, in that case, this system has two choices onto what about what to do with that heat. It can one store that heat as internal energy. Okay, it will store that heat as internal energy, and the internal energy of the system will increase, or it can use this heat to do some work on the surroundings. Okay, it can use this heat to do some work on the surroundings. Whenever you give it heat, it has two choices: either store or do some work. Now in this case hi Lokesha, in this case what I can write is, because of law of conservation of energy, guys, because of law of conservation of energy, the total heat given to the system will be equal to work done by the system plus change in internal energy. The total heat given to the system will be equal to work done by the system plus change in internal energy. Why am I saying this? Because this is the total amount of energy coming in, out of which this much is going out and this much is getting stored. Those are the two possibilities. It can either get stored or it can go back out again. Okay, so basically the total heat given to the system will always be equal to work done plus change in internal energy. Guys, if you understood, please give me a thumbs up. This is essentially first law of thermodynamics. Whenever they ask you what is first law of thermodynamics, this equation is the first law of thermodynamics. I hope you guys understood. Give me a thumbs up, guys. Give me a thumbs up. If you did, give me a thumbs up. You did not? Oh my god. Give me a thumbs down then. Give me a thumbs down in that case. Okay. Tamanna understood. Surinder understood. Very good, guys. Now, if you understand so far, then let's do a question based on this. Okay. Now, this might look like a hard question, but it's not a very hard question. You can do it. Okay. So it's just a lot of wordings here and there, but you just have to use one equation. Okay, so guys, what is the question here? The question says that a gas is compressed in a cylinder by a movable piston. Uh, to the volume half of its original volume. A gas is compressed in a cylinder by a movable piston to the volume half of its original volume. 300 kilojoules of heat leaves the gas and internal energy remains the same. You have to find the amount of work transfer. You have to find the amount of work transfer. Now guys, if you make a diagram of this system, okay, I don't know what exactly is happening, but the thing that I understood so far from this question is that 300 kilojoules of heat is leaving the system. 300 kilojoules of heat is leaving the system. In this case, guys, what will I write the value of Q as? I will give you two options, okay? Either plus 300 kilojoules or minus 300 kilojoules. Tell me which one will I write? Tell me which one will I write? What will I write the value of Q as? Yes, Tamanna, there will be regular class. There will be regular class. Yes, 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 yes. No more revision sessions. No more revision sessions. Okay. Will it be 300 or minus 300? 300 or minus 300? Guys, you have to remember when heat enters the system, it is considered positive. When heat is actually leaving the system, it will be considered as negative. Please remember, in this case, this will be, oh my God, color change. Okay, in this case this will be considered as correct and the other one will be considered as incorrect. Heat will be considered as positive negative because it is leaving the system, because it is leaving the system. Please remember that heat leaves the gas. Okay, also at the same time, guys, if I ask you the value of delta U, the value of delta U is given in the question. Tell me what is the value of delta U given in the question. What is the delta U given in the question? I will give you two options. The value of delta U will be same or value of delta U is equal to 0. Tell me. What will be the value of delta U? Same or 0? Same or 0? Same or 0? Same or 0? Huh? Okay, Kaushik is saying 0, Surinder is saying 0. What will be the correct answer, guys? Once again, if you see here, what happens is U will be same. Okay, U is internal energy, that will be same. What is delta U? That is change in internal energy. That is the final internal energy minus the initial internal energy. Now, if internal energy remains the same, what will be final minus initial? That will be 0. So remember that in this case, once again, delta U is 0 is correct and delta U is equal to same is incorrect. Okay, U is same, delta U is 0. U is the same, delta U is 0. Hi, hi. Athya, if you have doubt related to this, very good. If you have doubt related to anything else which is not taught in the lecture right now, I suggest you send me a message on Telegram. Aaditya Aaditya 832. Okay. Yeah. Tawheed, yeah, you can ask me about on Telegram. Okay, Tawheed, I hope you understood. Okay, मैंने P भूल गया क्या नहीं सब है सब है. Alright, guys. So if you understood this question, let me give you one more question. Okay, now this question is a graph-based question, but I think you guys can solve. So I have the graph is not given here. Let me make the graph. Let's say I have a P versus V graph. Okay, I have a P versus V graph. Okay, and what does this graph look like, by the way? What does this graph look like? The graph looks something like this. The graph looks something like this. Okay, where does this graph start and where does the graph end? The graph starts, okay, at volume V naught and goes to volume 2 V naught, and the pressure at the entire time remains P naught. Okay, you have to find the change in internal energy, the work done, the heat given to the system, everything for this case. Guys, I will give you 1 minute. I think you guys can solve. Okay, I think you guys can solve. We give you 1 minute. Tawheed, if you have doubt related to today what I'm teaching, then you can ask me. Otherwise, I would suggest you ask me on Telegram. Okay. Hi Shuyash, welcome to today's class. थोड़ा late हो गया Shuyash. Alright, how to do this, guys? Remember the formulas. Okay. These might seem like hard questions, but formulas, if you remember, you will be able to solve all of them. Okay. Surender is correct. Work done will be P naught V naught. Okay. Alright guys, since this is the first question, let me try to explain this for you. Okay, how to do this. So first of all, guys, first of all, if I ask you what is the change in internal energy, what will that be? That will be F by 2 into P final V final minus P initial V initial. Okay, now in this case, guys, what will be the value of F? They have given that the gas is diatomic. That means the value of F will be 5. The value of F will be 5. Okay, also guys, what they have also given, what they have also given is that the gas goes from this initial point to final point. You know what, I will name these 2 points. Let's name this A and B. So gas is going from A to B, so that means B is the final point and A is the initial point. B is the final point and A is the initial point. What will be the pressure finally? That is P naught. What is the volume finally? That is 2 V naught. What is the pressure initially? That is P naught. And what is the volume initially? That is V naught. Okay, so you can substitute all of these values. You can substitute all of these values into this equation to get. You can substitute all of these values into this equation to get delta U is equal to 5 by 2 into P naught times 2 V naught minus P naught V naught. Okay, or this will just become 5 P naught V naught divided by will just become 5 P naught V naught divided by 2. I hope everybody understood. Kaushik and Surinder got the same answer. Very good, guys. Very good, very good, very good. Okay. Also, at the same time, guys, let's say you want to calculate the next thing, which is the work done. How do you calculate work done, guys? How do you calculate work done? This is 5 P naught V naught by 2. You want to calculate work done. How do you calculate work done? You have to remember work done is going to be equal to area under the curve, which will be equal to area of this rectangle, which if you try to calculate, it will be height into base length. Okay, it will be base length into height. What will be the height? P naught. What is the base length? V naught. So overall it will be just P naught V naught. I hope you guys understood. I really hope you guys understood. Okay, then finally, guys, remember this. In most of the cases, whenever they ask you what will be the heat, whenever they ask you what will be the heat, always try to use this because this will work in almost all the cases. First, calculate work done, then calculate change in internal energy. You add them and you get the the heat given to the gas. So it will be P naught V naught plus 5 P naught V naught divided by 2. This will overall become Q is equal to 7 P naught V naught divided by 2. Okay, this will be 7P. Yeah, Surinder is correct. Exactly, guys. Exactly. Okay, I hope everybody understood. Now, guys, same thing for one more question. This time try to do it on your own so that I know that you have, I can confidently say that you can solve it. Okay, this time instead of a normal process like that, I am going to take a process like this. Okay, this goes from A to B. Okay, and the process is actually given to us. The process is actually given to us as an isothermal process. The process is actually given to us as an isothermal process. This pressure is 2 P naught. This volume is V naught. This volume is 2 V naught, and this pressure is P naught. Okay, find the value of change in internal energy, find the work done by the gas and heat given to the system in the following case. Once again, the gas is diatomic. Try to solve it on your own, guys. Once again, the gas is diatomic. You try to solve it on your own. Okay, how to solve this? How to solve this? Delta U is always has the same formula, guys. It never ever changes. Okay, the formula for delta U is always the same. It's F by 2 into P final V final minus P initial V initial, or F by 2 into N into R into T final minus T initial. Okay, Everybody. Work is NRTLN2. Kaushik, if you see, I have not given N or R or T here. I have not told you what is the number of moles. I have not told you what is the temperature. You have to give me the answer in terms of what is given in the question. Okay, no issues, Shruti. This is the second question for the day. We have to calculate the work done and change in internal energy. Okay. Kaushik, the second answer is correct. Okay. Ha, hey there is Agya. Hey there. Hi, hey there. Hi, how are you? Is that Atharva Sharma? Is that no? That's not Atharva Sharma. That is क्या नाम है? भैया? हाँ, work done is Surinder is correct. Work done is Kaushik फिर से थोड़ा सा गलती करती है. Okay. So, guys, what to do or how to do it? First of all, if you calculate the change in internal energy, that is F by 2 into P final V final minus P initial V initial. Now, you have to understand here that A is the initial point and B is the final point. So, if I ask you what is the pressure at the final point and volume at the final point, you will say, sir, B is the final point, pressure at B is P naught, volume as B is 2V naught. Okay, so this will be pressure and volume at the final point. And pressure and volume at the initial point will be equal to what? Pi and Vi. Their value, pressure initially is 2P naught and volume initially is V naught. Because point A is the initial point. Point A is the initial point. Now, substituting this, guys, what you do is you just substitute all those values in the correct, in the big question. So you get delta U is equal to 5 by 2 into, sorry, delta U is equal to 5 by 2 into P naught times 2 V naught minus 2 P naught times V naught. Okay, if you calculate this, this will come out as 0. This will come out as 0. Okay. F will be given by Tamanna. F is the degree of freedom. It is given by the degree of the gases, the atomicity of the gases. Okay. If you have a diatomic gas, then the value of F will be 5. Please check out my lectures on KTG if you are confused about that. Check out my lectures on KTG if you are confused about that. Okay, then finally, guys, if you want to calculate the work done, it's not finally, but yeah, if you want to calculate work done, you have to remember that work done is going to be what? Work done is going to be area under the curve. Work done is going to be area under the curve. But there is a problem here, guys. There's a big problem. What is the big problem? That this process is isothermal. How do I calculate this area? Can I consider that a circle? No, I cannot. Can I consider that an ellipse? No, I cannot. It's a hyperbola actually. Okay, you might not have even studied hyperbola right now. So I cannot use this here because I will not be able to calculate the area. What I will instead do is I will look at my formula sheet here, guys. If you look at my formula sheet here, oh, there's a formula for work done in an isothermal process. Do you see this? Do you see this? So what you can do, guys, is you can use that. Okay. So what you can do is, where is it? Where is it? Yeah. What you can do is you can write it as nRT ln V final by V initial. Now, once again, guys, you have to remember that N and T are not given in the question anywhere. But I have another superpower in my hand. You know what? There are 6 formulas here. You have to remember P initial, V initial will be same as P final, V final will be same as N into R into T. Okay, so substitute that here. Whatever you want to substitute P initial, V initial, substitute that, substitute P final, V final, substitute that. So I can just write delta W is equal to Pi Vi ln Vf by Vi. Okay, just substitute that, my friends. If you do that, what will you get as the correct answer? So when you do that, guys, when you do that, you will get, you will substitute initial pressure. See, A is the initial point. What is the pressure there? 2P naught. What is the volume there? V naught. And I also want the final volume. V is the final point. What is the volume there? Final volume is 2V naught. So substitute this here, guys, and what you get is, if you substitute it there, what you get is this. It will be equal to 2 P naught into V naught into ln 2 V naught upon V naught. Okay, which will just be equal to, which will just be equal to 2 P naught V naught ln 2. Okay, this will be the value of work done. Okay, now that you know work done, you can easily calculate delta Q, guys. What will be delta Q? What will be delta Q? Delta Q will be just equal to delta U plus delta, delta Q लिख देता हूँ मैं बार बार. Q is equal to heat given to the system will be equal to just work done plus change in internal energy. So that will just be equal to 2 P naught V naught ln 2 plus 0. That's how you calculate this. I hope you guys understood. If you did, please give me a thumbs up. If you did, please give me a thumbs up. Okay, now, if you understood this, guys, then let's go to the next topic. Okay, what exactly is the next topic? What exactly is the next topic? Adiabatic process. Okay, adiabatic process might seem like a lot in the beginning, okay, but one or two things I will not be able to derive because it's just waste derivation. I will just explain it to you. Other things I will derive. Okay, so first of all, if I have an adiabatic process, what exactly is the definition of an adiabatic process? By the way, the definition of an adiabatic process is that the heat given to the system should be equal to zero. There is no heat exchange with the surroundings. No heat exchange with the surroundings. So in this case, if I take a system, that system is supposed to be in an adiabatic surroundings. Okay, what that means is that if these are the wall of the containers, these wall will be thick and probably filled with vacuum so that there is no heat transfer. What type of walls are these, by the way? What type of, I had taught you, right? There are two types of walls. These walls are also called somethings. What are these walls called? Tell me in the chat, what are these walls called? These walls, guys, are called. हो एक भी आंसर नहीं आया. हाँ, wow. What are these walls called? You should know this. Yeah, Kaushik is correct. These are called adiabatic walls. Okay, these are called adiabatic walls because they do not let any heat transfer through them. Okay, so in this case, there is no heat transfer, there is no matter transfer, whatever is inside stays inside. Okay, so heat given to the system is equal to zero. Now, if I expand or compress the gas, what will happen is it will either heat up or cool down, and I want to know what will happen exactly. So here, what you essentially write, guys, is this. Okay, very simple equation. Q is equal to W plus delta U. Heat is equal to work done plus change in internal energy. Now, if Q is equal to 0, that means W plus delta U is equal to 0. That means W will be equal to what, guys? W will be equal to negative of delta U. Now, I don't know if you guys know what is negative of delta U, but delta U is essentially equal to F by 2 into P final V final minus P initial V initial, or F by 2 into N into R into T final minus T initial. You just use this formula to calculate delta U, and once you know delta U, guys, what can you calculate? Once you know delta U, you can calculate W. Okay, once you know delta U, you can calculate W. I hope everybody is following. Nothing super duper for extreme fun. Okay, I hope so far everybody is following. Really hope so far everybody is following. Okay, alright. I hope everybody's following. Seriously, I hope everybody's following. Okay, now guys, there is one more thing about क्या बोलते हैं? There's one more thing that you need to understand about adiabatic process. Okay, there's one more thing you need to understand about adiabatic process, and that is this. Okay, I will make a new slide here, and yeah, talk in that new slide. Okay, now if you see, if you talk about an isobaric process. Now, oh my God, what am I doing? Yeah, if you talk about an isobaric process now, so in that isobaric process, pressure is constant. That means the final pressure will be same as the initial pressure, or you can also say that volume by temperature is constant. Basically, what you can say is that V1 by T1 will be equal to V2 by T2. Similarly, guys, if you remember for isochoric process, what is constant? For an isochoric process, volume is constant, which means that pressure by temperature is constant, which means that initial pressure by initial temperature will be same as final pressure by final temperature. Okay, similarly for isothermal process, guys, what is constant? What is constant for an isothermal process? The temperature is constant, which means that P into V is constant, which means that P1 V1 will be same as P2 V2. Remember, P1 V1 equals to P2 V2. It's not valid everywhere. Okay, it's only valid for isothermal processes when the temperature is remaining constant. Okay, similarly, guys, for adiabatic process also we have equations like this. Now there are complicated derivations to that equation, and it's not useful for you guys to know that, so we'll skip that. Just right now, believe me that when I tell you that for an adiabatic process, you know what is constant for an adiabatic process. PV raised to the power gamma is constant. PV raised to the power gamma is constant. Okay. Now, if you want the derivation to this, guys, I will upload it alag se. If you want it, please write down in the comments. I will upload it alag se. But right now, I'm not going to do it. Okay. And what that means is P1 V1 raised to the power gamma will be same as P2 V2 raised to the power gamma. Whenever you see a first statement, do not think of it like the first statement. Always think of it like the second statement. The relation P1 V1 raised to the power gamma will be same in the initial state and in the final state. Similarly, from this, we can also derive, because if you guys remember, PV is equal to nRT. Do you guys remember that? PV is equal to nRT. That is always true because that is the ideal gas law. Okay, so if you remember this, PV is equal to nRT. From this, guys, I can write P is equal to nRT by V. Okay, and I can substitute it here. PV raised to the power gamma is constant, so N into R into T by V into V raised to the power gamma is constant. That gives me TV raised to the power gamma is equal to constant upon N into R. Now this constant upon n into r, you have to remember, is another constant. Now many times students ask me, sir, what is the value of that constant? It doesn't matter. You don't have to pay attention on the constant here, guys. What I'm trying to say with this statement is this. What I'm trying to say and what you have to remember from this statement is this. T1 V1 raised to the power gamma should be equal to T2 V2 raised to the power gamma. The value of this constant is immaterial. It will never be given. You will never calculate that constant. That is not of any significance here. What this statement means is the second one, and you have to pay attention to that. You have to pay attention to the second form of that statement. Okay, similarly, I have PV is equal to nRT. I can also write it as V is equal to nRT by P and substitute it in the first equation. P into nRT by P raised to the power gamma is equal to constant. That gives you one more equation that looks same complications. P raised to the power 1 by gamma, T raised to the power gamma is equal to some different constant. Once again, do not pay attention to that constant. Pay attention to what it means. That means that initial pressure raised to the power 1 minus gamma into initial temperature raised to the power gamma will be same as final pressure raised to the power 1 minus gamma into final temperature raised to the power gamma. This is how you are supposed to think about it. This is how you are supposed to think about it. Okay, so you have three different equations here. PV raised per gamma is equal to constant, TV raised per gamma minus 1 is equal to constant, and P raised per 1 minus gamma, T raised per gamma is also equal to some constant. Don't pay attention to the value of that constant. The value of that constant is not important. What is important is what it means. Okay, I hope you guys understood. Now, the derivation of this, guys, I'm not going to do it right now. The derivation of these, I'm not going to do it right now. I will do it in an extra video if you want it. Okay. But for according to me, they are not important. So I will not, I don't want to do it. Also remember, what is gamma? People are too confused here, sir. What is gamma? Okay, so you have to remember what gamma is. Gamma is essentially what? Gamma is essentially Cp by Cv, and its value depends on the atomicity of the gas. Its value depends on the atomicity of the gas. If you remember, we have three different types of gases: monoatomic, diatomic, and triatomic. Triatomic, when we talk about non-linear gases. Okay, and we have a different formulas. First of all, if I talk about degree of freedom, it will be 3 and 5 and 6. If I talk about the formula for Cp, that is F by 2 plus 1 into R. Okay, if I talk about the formula for Cv, it will be just F by 2 into R. So substituting that here, guys, I can write the value of Cv as 3 by 2 R, 5 by 2 R, and 6 by 2 R. Also, at the same time, I can write down the value of Cp for all three of them. That will be equal to 5 by 2R, 7 by 2R, and 8 by 2R. And finally, what is gamma? Gamma is the ratio of Cp and Cv. It will be 5 by 3 or 7 by 5 or 8 by 6, which is 4 by 3. Okay, I hope everybody understood. So, Rudra Patidar, which part you want me to explain? Cp by Cv, that is given in the previous video. If you have other doubts related to previous videos, Rudra, please contact me on my Telegram at AADITYAP832. Okay, I hope you understood, Rudra. If you can, just message me on Telegram. All right. So these are the formulas. By the way, I can also write down these formulas in terms of gammas. This will be equal to gamma r upon gamma minus 1, and this will be equal to r upon gamma minus 1. Okay, I can also write down these formulas in terms of r. In this case, it's very important that you remember the formulas and you remember the value of f. It's very important that you remember the formula. I'll just tick mark whatever is very important for you to remember. Okay, you have to remember this, you have to remember this, and you have to remember this. If you remember this much, and also if you remember this much, then you can calculate the rest. Okay, these are the important parts. Everything else is just calculations. Okay, everything else is just calculations. Everything else is just calculations. I hope everybody understood. Really hope everybody understood. Okay, now next is, guys, next is, if you understood so far, then what we are going to do is talk a little bit more about adiabatic process. Okay, now in case of adiabatic process, once again, their notes I don't like, I'm going to remove. Okay, and the work done in an adiabatic process, what is the formula for work done in an adiabatic process? I hope everybody remembers it. It's not going to be anything else, it's just negative of delta u. Just remember the formula for delta u, and remember that it's going to be negative of delta u. Remember the formula for delta u and just do negative of that. Afra Paiju, yes, my friend, unfortunately, yes. But the thing is, if you do enough questions, now do like 30-35 questions, you will automatically remember all the formulas. Just do some questions, you'll remember the formulas. Okay, all right. Sorry, Afra. Sorry. But you have to remember. Okay. Now, guys, based on this, I hope everybody understood. Okay. Also, at the same time, remember, if I have an adiabatic process, now the graph of adiabatic process looks similar to what? Graph of adiabatic process looks very similar to isothermal process. Okay. The graph of adiabatic process looks very similar to isothermal process. Okay, but if I have to give you more details here, which they have not given, let me give you more details here. Where is it? Where is it? कहाँ गया इनका? अरे, Control Z. Huh. If I have to give you more details here, guys, then you have to remember that if I have P versus V graph, then in this case, the adiabatic graph is steeper than isothermal. Okay, what that means is that if I have an isothermal process given by this graph, Okay, you know what? I'm going to make it like this. Yeah. If I have an isothermal process given by this graph, then an adiabatic process will be a graph which is steeper than that. What that means is it will decrease faster. This will be an adiabatic graph. Adiabatic graph is a steeper version of isothermal graph. Why does it look like this? Why does it look like this? Because you have to remember, for an isothermal graph, p raised to v p v p into v into p into v raised power 1 is constant. For an adiabatic graph, p into v raised to the power gamma is constant. Okay, if you try to plot these two graphs, this is how their shape will look like. This is how their shape will look like. So just remember it like that. Just remember it like that. Okay, I hope you guys will remember this. There's a lot of information here that you just need to remember. Okay, all right. Based on this, guys, let's do this question. 170 kilojoules of heat is supplied to a system at constant volume. Okay, 170 kilojoules of heat is supplied to a system at constant volume. Then the system rejects 100 kilojoules of heat at constant pressure, and 40 kilojoules of work is done on it. Finally, the system is brought back to the initial state by an adiabatic process. If the initial internal energy is 100 kilojoules, then find the highest value of internal energy throughout this cycle. Okay. Oh my God, what a question, yeah. What are they even trying to tell you? What are they even trying to tell you? Let me tell you what they're trying to tell you. Okay. So let me try to start by making a P versus V graph. Okay. Let me try by start by this. Okay. Now what happens is the 100 kilojoules of heat is supplied to a system at constant volume. Okay, so what happens was that a system, let's say, was starting here, okay, at point A. Now what you are doing is you are supplying heat to a system at constant volume. You are supplying heat to the system at constant volume. So basically what happened is, you know what, I will start A somewhere here. What happens is that the system will go from here to here. Okay, why did I make it like this? Why did I make it like this? Because the heat is supplied to the system, so basically the gas will get heated. Okay, also at the same time you have to remember the Q value from A to B is going to be equal to 170 kilojoules. Okay, Q value from A to B is going to be 170 kilojoules because heat is supplied at constant volume. Heat is supplied at constant volume. Okay, then what happens is then the system rejects 100 kilojoules of heat at 100 kilojoules of heat at constant pressure, and 40 kilojoules of work is done on it. What that means here, guys, what that means here is that from this point the system goes in this direction. The system goes in this direction. Why am I writing the system going in this direction? First of all, heat is coming out of the system. Heat is coming out of the system. The system is rejecting heat. So the gas will cool down and its volume will decrease. Okay. And secondly, it is doing that at constant pressure. It is doing that at constant pressure. So you have to remember that in this case, this will be the situation. Now here, if I ask you what is Q from B to C, you have to remember it is minus 100. And if I ask you what will be the value of work done from B to C, that will be equal to minus 40, because work is done on the system. Work is done on the system. I hope you guys understood. I hope you guys understood. Okay, and then finally the system is brought back to the initial state by an adiabatic process. So basically what I do is I take the system from here to here in an adiabatic process such that Q from C to A is 0. Okay, why did I write Q from C to A as 0? Why did I write Q of C to A as 0? Because it's an adiabatic process. Because it's an adiabatic process. Guys, I hope you guys understand. Now, from this, how do we solve this? From this, how do we solve this? So guys, let me just, let me just remove this and remove this. Oh my God. Oh, okay. So in this case, guys, if also one last thing they have given, I forgot to tell you, one last thing they have given. What they have given is the potential, the internal energy is initially 100 kilojoules. Basically, what they've given is internal energy of the gas at point A is 100 kilojoules. Okay, you have to find basically UB and UC. You have to find basically UB and UC and then tell me which one of all the three is highest. You have to find all these three and then tell me which one of all these three is highest. Okay, so how do I calculate all of these, guys? How do I calculate all of these? So first of all, what you need to understand is you need to find out the value of delta U. What does delta U represent? What does delta U represent? Delta U represents Tamanna. Sorry, no mentees tomorrow. Okay, no mentee quiz tomorrow. So what does delta U represent? Delta U, we will have a doubt sorting session on Monday. No mentees, no mentees. Okay, what does delta U represent, guys? Delta U represents the change in internal energy. So if I go from A to B, what will be delta U? What will be delta U? If you have an equation Q is equal to W plus delta U, that means this will be equal to Q minus W. This will be equal to Q minus W. Okay, but which Q minus which W? We are going from A to B, so that is Q from A to B minus W from A to B. Q from A to B minus W from A to B. I hope you guys understand. Really hope you guys understand. Now, do you guys know what is Q from A to B? Do you guys know what is Q from A to B? What is Q from A to B? Q from A to B is just 170. What is W from A to B? Nothing not given here. What is W from A to B? Oh my God. What is W from A to B? Oh my God. Oh my God. Oh my God. How do I calculate that? What will be W from A to B, guys? What will be W from A to B? Can anybody tell me? Anybody? La 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 la. It will be zero. Why will it be zero? Why will it be zero? Because it is going up. It's an isochoric process. Area under the curve will be zero, and therefore work done will also be zero. Okay, yeah, area under the PV graph, work done will be zero. So this just comes out as 170. Similarly, guys, if I ask you delta U from B to C, how do you calculate delta U from B to C? And how do you calculate delta U from B to C? Surinder, you are correct. How do you calculate that? You will calculate that as Q minus W once again, but this time you will write BC and BC. Okay, now both these values are given. This will be minus 100 minus 40. This will come out as minus 60. This will come out as minus 60. Now, guys, what are the use of these two values? Okay, let me just remove all of this kachra and write properly. Okay, let me just remove all of this because it's distracting to have so much on the screen. Okay, let me just remove all of this. Okay, this also you are useless data now. Go away. Okay, useless data, useless data, useless data. Okay, so delta U A to B I got as 170, delta U B to C I got as negative 60. Now what does that give me? Okay, what you have to understand is this is change in internal energy. U at A is given to me as 100. What you have to understand is U at B minus U at A will be nothing but change in internal energy from A to B. That will be nothing but UAB. Okay. No, Kaushik, I wouldn't consider this as an advanced question. Okay, I wouldn't consider this as an advanced question. So I can write this as UB minus UA, UB minus 100 is equal to 170, which gives me UB is equal to 270. Kaushik, did you get the correct answer on your own? This is a good mains level question, guys, but I wouldn't consider it as an advanced level question. Okay, this is a good mains level question, not an advanced level question. Then next, guys, if I have to calculate UC, what will I do? If I have to calculate UC, I will similarly use this. Okay, I already know that UB is equal to 270. What I will write is next UC minus UB will be equal to UBC. That will be the change in internal energy. Final minus initial is always the change. okay, which gives me UC minus 270 is equal to minus 60, which gives me UC as 210. So UC as 210. Now tell me guys, which one is the highest and how much is the highest value? Which one is the highest and how much is the highest value? B is the highest and the value highest is equal to 270. The highest value is 270. Option A is the correct answer. Option A is the correct answer. I hope you guys understood, guys. If you did, please give me a thumbs up. If you did understood, please give me a thumbs up. Did you? Did you? Yup, yup. Yeah, very good. Kaushik and Fab Phoenix, both of you understood very good. Now, guys, let's talk about the heat engine. Okay, let's talk about the heat engine. बहुत खाली है यार ये लंच के बाद वाली क्लास में है ना बहुत डकार आती है. Anyways, yeah. Okay, so let's talk about heat engine. Okay, an engine is a machine designed to convert one form of energy into mechanical energy. Basically, an engine is designed to convert. An engine is designed to convert heat energy into mechanical energy. Okay, heat energy into basically work. Okay, now it doesn't look, it's not as easy as it looks, guys, because if you look at any engine, if you look at any engine like this engine, you have to see that all engines run in cycles. Can you see that in this case? Can you see that in this case? The gas is expanding, the gas is compressing, the gas is expanding, the gas is compressing. Okay, all engines have to run in cycles. If you look at another engine, this is by the way an external combustion engine and this is called an internal combustion engine. Okay, वो फर्क वगैरह mechanical engineering पढ़ोगे तो you will understand automatically. Don't worry about it right now. The main thing you need to understand here is that here what it basically works on the principle of that the gas inside this chamber, the gas inside that chamber continuously expands or contracts. Okay, the gas inside that chamber continuously expands or contracts. That is the principle based on which it works. Okay, and that gas goes through cyclic process. Okay, I hope everybody understood so far. I really hope everybody understood so far. So now, if you look at components of a heat engine, that what exactly is happening in a heat engine. Okay, this is like actually how heat engines look like. This is exactly how Tamanna. We will do a poll today only. Okay, we'll do a poll today, and based on that, we will study. Okay, if you have any suggestions, please send me the suggestions on Telegram as well, but I will do a poll in the Telegram group today. Now, this is what an actual engine looks like, but right now we are not going to study this engine. Okay, what we are going to study is ready, ready, ready. 3, 2, 1, go. We are going to study this, guys. Okay, in the engine that we are going to study in this class, we are not going to worry exactly what happens inside this engine. We are not going to worry exactly what happens inside this engine, but we will consider it a very simplistic picture of that engine. What I will say is that in every engine, there is always a heat source. Okay, in every engine, there is always a heat source which provides heat to the engine, which provides heat to the engine. In case of your car or bike, that will be the combustion chamber inside inside the piston. Okay, the function of that source is to provide heat. Now, when that source provides heat, guys, what happens is that the engine, this is the engine here, the engine does some work through it. The engine does some work through it, essentially, basically rotating your tire or whatever, if it's a car or a bike, and rejects the little bit of heat into the surroundings and rejects a little bit of heat into the surroundings. Okay, if you have seen in your bike, you have a silencer at the back, and in the cars also you have a silencer at the back. And if you ever see the air coming out of that silencer is always very very hot. Okay, why is that air very very hot? Basically, the engine is rejecting some heat. Okay, and what we'll learn later is because of laws of nature. Okay, it's just because how nature is made, we always need to do this. We always need to do this, even though we hate wasting heat into the surroundings. That cannot be avoided. That cannot be avoided because of second law of thermodynamics. It has to happen. Okay, it just has to happen. It cannot be avoided. Now, in this case, guys, this is something which is desirable. This is something which is desirable. This is something we want more of. Okay, we want to have this as much as we can. Okay, and this is something that we want less of. Okay, this is something that we want less of. I want to minimize this as much as I can so that I can have maximum work output and minimum heat taken into the minimum heat taken from the source. Okay, so in order to tell people that how good my engine is, we define a factor called efficiency. We define a factor called efficiency. Efficiency. All right, this efficiency, guys, is written as eta. And what exactly is this eta? What exactly is this eta? This eta is going to be the total work done by the gas, the total work done by the gas divided by the heat given from the source. Total work done by the gas divided by the heat given from the source. Okay, now in ideal conditions when everything is perfect and I'm like I have very high temperature heat source and like what is the maximum possible efficiency that is possible? What is the maximum possible efficiency which is there? Okay, what is the max possible value of n? Not n, of eta. What is the maximum possible value of eta? Guys, you have to see this. The maximum possible value of eta is always going to be 1. The maximum possible value of eta is always going to be 1. Alright guys, I'm going to end this lecture here. I'm so sorry I'm ending this lecture on a very weird note and somewhere in between, but I'm going to end this lecture here and we'll continue the rest of this. Like approximately only half an hour is remaining, not more. Okay, only half an hour is remaining. We'll finish this in the next class. Okay, we'll finish that in the next class. Only half an hour is remaining, not more. We'll finish this in the next class. Okay, I'm so sorry I'm ending it abruptly somewhere, but it's already 1 hour. Okay, and also at the same time, guys, if you are a repeater and you want to get coaching from India's best coaching experts, and these guys are here on Vedantu to give you coaching. Okay, who are these guys? These are faculty from Alan Chandigarh. Okay, these are the top faculty from Alan Chandigarh, and they are on Vedantu just to teach you guys. They are on Vedantu just to teach you guys. Yeah, homework I'm giving Kaushik. Don't worry, don't worry, don't worry. Okay, homework I'm giving. Okay, Tamanna Bharadwaj. Next class will most probably be Sunday, Monday. I will put that on the Telegram group. Okay, don't worry about it. Okay, Telegram group pe you will see. Kaushik is asking, sir, do you watch IPL? Kaushik, I do watch IPL, but sparingly, not all the matches. Okay, I myself am a big fan of RCB, so I follow RCB. Okay, yeah. I don't know if are there any RCB fans here. Are there any RCB fans here? I don't know. Okay, so these faculties are from Allen Syndicate, guys. If you want to enroll into this, you can go through the link in the description, go to the Vedantu website and enroll for this course. But when you do, guys, please remember to use my coupon code AAPPRO, because when you use my coupon code AAPPRO, you will get 20% discount. You will get 20% discount. Okay, so do that if you want to do that. This is for JEE 11 and 12th and droppers. Okay, I hope everybody understood. You get a big discount, guys, when you enroll through this link. You get a big discount when you enroll through this link. Okay, all right. Yeah, this is अरे ये नीट वीट लिखा हुआ है क्या? I'm sorry, कहाँ लिखा हुआ है नीट? I don't know. This is JEE. Okay, no need. It's JEE. Okay. Alright guys, so that's it for today's class. I have to give you a homework question. Oh my god, I forgot to give you a homework question today, huh? Let me give you a homework question, guys. It's a very simple homework question. Okay, it's a very simple homework question. What I have is, question is very simple. Okay, so I have a P versus V diagram for a monoatomic gas. I have a P versus V diagram for a monoatomic gas. Okay, and that diagram looks something like this. That diagram looks something like this. It goes from A to B to C to D. Okay, you have to calculate work done from A to B, work done from B to C, work done from C to D, work done from D to A, and then you have to calculate the total work done, the work done net, which will be the sum of all of them. Okay, just add all of them. And similarly, you have to calculate U net and you have to calculate Q net and write this in comments. Write this in comments. Okay, comment section. Okay, just write this one in the comment section. I will give you the values here, guys. Don't worry. This will be equal to P naught. This will be equal to 2 P naught. P naught and 2 P naught. Okay, this will be equal to V naught and 2 V naught. And I will tell you that this is a monoatomic gas. Okay, write it in the comments. Write it in the comments, and I will share the notes. I will share the notes. Do not worry, very, very soon. Okay, I hope everybody understood, guys. Thank you so much for being here. It's lovely teaching you. Okay, Bhumika is asking, sir, which topic of thermal physics is most important? Then Bhumika, I would suggest that the most important topic is conduction, convection, and radiation. Basically, yeah, the heat transfer part, because JEE loves asking questions from that. So study that. And also, no. F is not one, my friend. F is three. Okay, F is not one. F is three. Okay, so yeah, F is three. So conduction, convection, radiation is the most important part. But anyways, all right, guys. So I will end today's class here. It was so nice teaching all of you, and I will see you guys again on. I will talk about it on the Telegram. Okay, when I'm coming on Monday, most probably Monday or Tuesday. Sometime I will. We will share the timetable on Telegram. Okay, and the next chapter will also start very very soon. Do not worry. I will ask which chapter you want next as well. Okay. Bye everybody. Bye 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 bye.